Alright guys, welcome to module 1 of Python basics. As I pledged, we'll be covering module by module. So in module 1, we're going to look at variables and names, data types, type conversion, operators, user inputs, and typecasting. So stay along. Welcome to module 1. So it entails Python basics where you will build a solid foundation in Python programming, and this module is designed for both beginners and those looking to strengthen their core Python skills. And each section includes clear explanation, practical examples, and insightful comments to help you grasp key concepts step by step. And by the end of this module, you will have a strong understanding of Python syntax, data types, variables, operators, control flow, functions, and more, equipping you with essential knowledge to start coding effectively. So let's dive in and begin your Python journey. So we're starting with variables. What is a variable? A variable is a named storage location in a computer's memory that holds a value. So it allows programmers to store, retrieve, and manipulate data efficiently. You can think of a variable as a labeled box where you can place different items or values and change them as needed. For example for a value box, you can equate to a box labeled, for example, pens, another box for books, another box for example, examination result. So now if you want examination result, you will go straight to examination to a box labeled examination result. That's example of a variable. If you want pens, for example, you have to maneuver to where to a box labeled pens, and so on and so forth. So why should we use variables? Variables make code dynamic and reusable, which means the box can be emptied and we insert or we use other variables as a placeholder. So instead of using fixed values throughout a program, variables allow for flexibility, enabling changes in data without modifying the entire code. So we're going to look at declaring and assigning variables in Python. So in Python, variables are created the moment you assign a value to them. Unlike some other programming languages, Python does not require an explicit declaration of variable types. So Python automatically determines the type based on the assigned value. So what do I mean by this yellow syntax statement? That Python does not require an explicit declaration of variable type. For example, if you ever interact with another programming language like Java or C++, so you need to remind the computer that yes, I'm giving you this value, but I need you to store it as, for example, a number. I need to store it as a character. I need to store it as a string, for example. But in Python, it automatically detects that this is the variable type that has been entered automatically. So we are going to learn more as we proceed. So we have some rules for naming variables in Python. For example, if you are visiting a new country, you'll have to adhere with that country's rules and regulations. So with also variables, we're introducing variables inside a computer. So we have some rules that will guide those variables to stay inside the computer without producing bugs, and in this case I mean some errors. Yes, so naming variables correctly is essential for writing readable and error-free code. So Python enforces certain rules when naming variables, and following best practices improves code maintainability and clarity. And below is a detailed explanation of the rules. So rule number 1 is that variable names can only contain letters lowercase a through lowercase z, comma, uppercase a through uppercase z, and it can also contain digits from 0 through 9 and underscores. So Python allows variable names to include letters, numbers, and underscores. But special characters such as at, hash, dollar sign, percentage sign, exclamation sign, and more are not permitted. We want to look at Python naming variables. So some of their rules. So let us dive in and summarize naming convention in Python. First rule, as we looked before, that variable names must begin with a letter, that is lowercase a through lowercase z, uppercase a through uppercase z, or an underscore. Number two, the rest of the variables name can consist of letters, numbers, and an underscore. Number three is that variable names are case sensitive. For example, variable var and var are different in Python phase. So number four, variable names cannot be a reserved word or a keyword. I shall look in the following section. So for example, of the examples of variable valid names include, for example, valid variable name 1 is equal to 10, which starts with a letter and uses an underscore as well. So valid variable number 2 is equals to 20. It starts with a letter and an underscore and a number. So an underscore var underscore name is equal to 30. Still, a valid name starts with an underscore. You so it's a valid name. So a var name is equal to 40, still also valid. It's case sensitive and it's different from var name in lowercase. So value 2, for example, is equal to 50. It contains an underscore and a number. So example of invalid variable names in Python include the following, and will cause an error or syntax error when you run without commenting them out. So example, 1 underscore invalid is equal to 60. So it contains a number or starts with a number, so it will throw an error. For example, def is equal to 70. So def is an inbuilt Python keyword and it will cause a keyword error. So at var name is equal to 80, so cannot contain space or special characters like at, among other special characters. So if you want to display valid variable names and their values, so this is what you can do. For example, using an f string, print f valid name variable 1, print f variable name 2, and print f value underscore var name. Then we use placeholder var name, and then last f print f var name name. Then moving ahead, we can look at, or you can check Python's inbuilt keywords using the following syntax. So first of all, you need to import the inbuilt library called keyword. And remember, I have commented out, but you should not comment out when you want to get the result. So to display the result, you just need to print Python. You need to print keyword.keyword list, and the result will be as follows: false, none, true, and, as, assert, async, await, break, class, continue, def, deal, elif, else, except, finally, for, from, global, if, import, in, is, lambda, non-local, not, or, pass, raise, return, try, while, with, until. So those are inbuilt keywords. We want to conclude on variable names. So following these rules ensure that your Python code is clean, readable, and free from common naming errors. So it's a good practice to always choose meaningful and descriptive variable names to make your program easier to be understood. The way I told you previously, that for example, if you want to list the names of students, it's good to say student underscore names, for example. It will be descriptive that indeed you are assigning these values to a variable called or a placeholder called students. So any person can understand your original idea. So it's a good practice, and you have to understand this as you have to start writing large chunks of code. So we are moving on to data types in Python. In Python, data types define the kind of data a variable can store. So understanding data type is crucial because they determine how operations behave and how data is stored and manipulated. So manipulation simply means that you want to use that data based on what you want. For example, do you want to use that data for just storage purposes only, just to use some sections, just to do some plotting, just to eliminate some unnecessary stuff? That's what you call manipulation. So, and common data types in Python include integer or int. So integer data type is used to store whole numbers only, and that is positive or negative, and they are without decimals. For example, age is equal to 25. 25 is a positive integer without any decimal place. Temperature is equal to negative 5. Negative 5 is an integer without any decimal place. So total underscore student is equal to 1,000. It's also an integer, but it's a large integer. So, and operations that can be done on an integer include arithmetic operations like addition, subtraction, multiplication, division, and you have two types of division. You have uh, floor division and normal division. So floor division, it means that it uses two forward slashes. 25 double forward slash 2. It means that you don't want to get a decimal value of that stuff. So let me give you an example. We want to look at integer manipulation in Python. So we want to look at basic arithmetic operations. So we need to import math, and x is y, x is equal to 10, y is equal to 3. Sum of the result is equal to x plus y. So we are doing addition operation. So you can also do a subtraction operation, and you can also do the multiplication operations. So moving ahead, you can also do division operation, just x divided by y, and the result will be a float. So you can also do module operation using a percentage sign, which means it will give us a reminder. You can also do exponential by using double asterisk signs, so which means x is raised to the power of y. So we can also do floor division using a double forward slash, which means we get the result without decimal point or a reminder. So we can now print the result. Sum is equal to sum result is 13. You can print subtraction is equal to sub the result to be 7, and you can also print multiplication result, which will be um, 30, and you can also do division, get the division result as 3.333. You can also print the modulus result, which is 1. So you can confirm from your side, and you can also print the exponential result, which is 1000. So you can also do print the float division result, which is 3. And moving ahead, you can do what you call type conversion using integers. So for example, string is equal to 1, 2, 3, and num int is equal to int num string, and the result should be 1, 2, 3 without strings in quotes. So float num is equal to 45.67. You can convert a float to an integer, which will be 45.67. Not for just 45, because it will be truncated. Then you can print the converted integer, and from a string, which will be 1, 2, 3. So you can also print the converted integer from float as 45. So you can also do bitwise operation, such as a is equal to 5 and b is equal to 3, which is 0.0011 in binary. So bitwise and a and b, you have to get AND operation. So bitwise or a or b, so either of the value. So bitwise XOR, so it will give you XOR operation. So we also have bitwise NOT, which is given as follows. So NOT operation, so inverse bits. So you can also do bitwise left shift. For example, a left shift 2, that's a left shift by 2. So multiplies by 2, which means 2 squared. And we have bitwise right shift, which is equals to a greater than 2. So we can also print bitwise and you get the result as 1, and bitwise or and result will be 7. So please confirm from your side, and bitwise XOR and the result is 6. So going ahead, bitwise NOT will be bitwise NOT, which is -6. So printing left shift, we get bitwise left shift as 20, and right shift, which is bitwise right shift as 1. So going ahead, you have for checking if a number is even or odd. So for example, we're defining is even, and we return n if n percentage 2, which is equal to 0, which means that if we divide it by 2 and we get 0, then it means that the remainder is 0, so it will be an even. So for example, if it's 10, it will be true. If 7 is false. So, and we can find the absolute value using an integer. So for example, negative number is equal to -10, and absolute value will be ABS, negative number, and the result is positive 10, as seen here. So please do the necessary from your machine. Number 6 is maximum and minimum of an integer. using Python. So for example, maximum value is equals to max 10, 20, 30, and 5. So maximum value, you say, for example, mean value is equal to 10. We can print the maximum value now as max val as it will be 30, and mean val will be in this case 5. So moving ahead, we can do power and square root. So in Python we can do power, so that we use power keyword, and this one will raise the number by the result, by the value that you will have to declare. So for example, square of the result equals math.square keyword. So if you print the power of the result, you get it's at 8. So 2 raised power 3, you get an 8 as value. So square root, you can also use square root result to be the 4 as value. So you can also do factorial calculations. For example, factorial result is equal to math.factorial 5. So it should give you 5 times 4 times 3 times 2 times 1. So if you print factorial of 5, you should get the result as 120. So the greatest common divisor, or GCD, can also be performed using Python. So for example, math.gc. So the error you are getting because it's not recognizing the math library, but you imported it before, you can still import it, so the error can go away. So we're going to look at the second data type, that is floating point, or just a float. So floating point value is any number that has some decimal places. For example, pi is equal to 3.14159. It has some decimals. Temperature cannot be an exact value, so the same to height, and also discount can never be a whole number like 1%. 1% is not meaningful discount, because the price will still remain the same. So it will always be a decimal place. So operations that can be performed on floating point. Guys, let us look at floats. So we start by importing math. So float manipulations, so in Python. So remember, I just commented out math, but we shall use that library later, which I will comment out. So basic arithmetic operations with float. We do the following. So for example, x is equal to 10.5 and y is equal to 3.2. So you can have its summation, and sum result is equal to x plus y, and that's simply an addition. And you can also do subtraction, which is x minus y, and that's a subtraction in a nutshell. You can also do multiplication, and that's mul result equal to x times y, that's multiplication. And you can also do division of the result using normal division. So x and by y, that's division, returns the float. That's module result is equal to x percentage y. So that's modulus operation with remainder of division. So exponential or result, you can do it using double asterisk of exponential, so which is x to be raised to the power of y. So we can also do a float division of the result, that is x forward slash y. So that's float division, or quotient without remainder. And you can also print now the above result sum. You can also print out our subtraction result the same way to multiplication, exponential. So I'm going to print all the results, and that is displayed. So you should be doing this to your machine and validate that indeed what I'm getting is exactly what you are getting from your side, so we don't clash on the outputs. So most I'm focusing on code writing, so I won't be running this. However, you can try there from your side, but I had tested before doing this. So you can also print the exponential as a result. So exponential result in this case 1326.4 all the way to 2.8. So you can print also the flow division and result as follows. So 3.0. So number 2 is type conversion. So for example, num string is equal to 123.45. So num float should be a float of num string. So we're expecting something like 123.45 without or quotation marks. So we can also do int num. So you go to int num float. So you're converting a float to an integer. Using Python, so it truncates all the decimal values, so you need to take that caution. So you can also print converted a float a comma will be num float, so which it will be as I had said before or earlier. So you can also print converted integer as int num which will be 123. So number 3, you can do rounding off of a float value. So for example, rounded value is equals to a rounded 3.1459 in 2 decimal places. So a comma, you can put in the number of decimal places you want. So printing the rounded value will be 3.14 at the output. So moving ahead, you can do finding the absolute values of a float. So for example, negative float is equal to negative 10.75, and absolute value will be a positive 10.75 as follows. Yes, so the negative value will be removed. And then number 5, can look at how to calculate maximum and minimum of a float. So for example, maximum value is equal to max of 10.1, 20.2, and 30.3, then and 5.5. So minimum value will be min of 10.1, 20.2, 30.3, and 5.5. So printing the max value will be max value, so it will be 30.3 in this case, and minimum value will be 5.5 as can be seen. Remember, we're just using a minimum list, but you can use extremely large size of data. So we're looking at power and square root with floats. So for example, we're importing math, and power of the result will be power of 2.5 comma 3, which means we are raising 2.5 by 3. So you can also do square root of the result, which will be math dot square 16. So which and the value will be as will be printed below. So let us proceed and you see the result. So that will 15 point so you can also do square root as it will be 4. Square root of 16 is 4. And logarithmic functions you can also do for example, logarithmic result is equal to math.log 10.0. That's a natural logarithm that of base e. So we can also do log 10 result, which means math.log of 10 base 1000, so which means logarithm of base 10. So we can also print natural logarithm of 10 is equals to approximately 2.302. So we can also print the log base of 1000 to be 3.0. So you can also do trigonometric functions in Python. For example, sine value is equal to math.sine math.radians 30. that is a sine of 30 degrees, and you can also do cosine value is equal to math dot cosine math dot radians 30, sorry 60, and it will be the cosine of 60 degrees. So proceeding ahead, you can also do tangent value, it will be math dot tangent dot math dot radians, that's 45. So that is the tangent of 45 degrees, and you can now print the respective results. So the sine 30 degrees, it will be 0.5, and printing the cosine of 60 degrees as well is going to be 0.5. You can also confirm with your calculator. So the tangent of 45 degrees, from my end, I'm getting the value as 1.0, and that is it. Thank you. So another data type in Python is a string. Sometimes we call it a star. So it's a sequence of characters enclosed in single quote, double quotes, or a triple quotes. So it's used to store text data. That's the main function of a string, used to store text or textual data. For example, you can say name is equal to Alice. So it's quoted Alice in this double case. So in the double quotes, greeting is equal to hello world in lowercase, and we have paragraph is equal to, this is a multi-line string. Then string support uh, strings support concatenation, or just combining some strings with another. I can also support repetition. They can also support some slicing. So we're going to do this example. So let us head to Python. String manipulation. We're looking at number one as concatenation or combination. So first is equal to hello, second is equal to world, for example, and we want the result to be the result of first and second, so we add them with the separation, and we print the result. The output should be hello world. So number two, we are going to look at repetition of a string. Text is equal to Python, and so you can print by Python times 3 is equal to Python, Python, Python. So next we're going to look at string slicing or indexing. So text is equal to Python programming, for example, and print text from position 1 to 6, you get the output as Python. And you can also print text at -3 all the way, you get ing, which is the last three stuffs, and you can also print text in reversal order. So we start it by G, N, I, etc. up to all the way to P in reversed order. So this is how you can reverse a string. Number 4, we are going to look at changing the case. So for example, text is equal to hello world. So we can print text dot uppercase to uppercase the text. It will be hello world in uppercase. You can also print text dot lower to get the hello world but in lower cases. And the next we're going to get text dot title case, which means that every word is going to be capitalized. Sorry, every word is going to be is capitalized. So string capitalization, which means first letter to be capitalized, and then we are going to look finding and replacing a string. We can get where Python is the index. We get it's an index 7. We can also replace, for example, text.replace keyword with Python with Java, and so the output will be I love Java instead of I love Python. And then splitting and joining the text or the string. So text, for example, is apple, banana, grape. So the fruits will be text dot split. We want to split by comma. You will get a list of the fruits. So the output should be square bracket apple, banana, and grape. So joining the text, you can also join by underscore, minus, or any other stuff you want. So the join text will get as apple dash banana dash grape. So number 7, you can see string stripping white spaces in a string. So text is equal to hello world with left strip and right strip. So text dot strip will get all the spaces has been stripped away. Now text dot l strip, only the left side will be removed. The space in left hand side will be removed, right will remain unchanged. And the same way will happen to r strip. The left side will be left unchanged. And moving ahead, I'm going to look how to check string properties. So for example, text is equal to Python 1 2 3, and you print text dot is alphanumeric. So this one will give output as false since it contains numbers. And is text a digit? No, since it contains some letters or characters. Yes, the other thing we're going to test is text dot is alphanumeric. That should be true because it combines both letters and numbers. And you can also check if it's a space or an empty string. So this one will give us a false because it contains alphanumeric stuff. Number 9, we're going to look at string formatting using f string. So f string helps us to use it as a placeholder. So for example, name is equal to Alice, age is equal to 25, and you can print f. My name is and age here. So the output should be my name is, where name is as a placeholder it will be plugged in as Alice, and where age is will be plugged in as 25 years old. So my name is Alice and I'm 25 years old. Moving ahead, we want to do how to reverse a string. So text, for example, is equal to Python print text in reversal order. So the output should be the reverse string. Boolean, or sometimes we call it bool, and they represent logical values, that is true or false, and they are used in conditional statements and logical operations. For example, is underscore dummy, sorry, is underscore sunny, is underscore sunny, we will say true. For example, if it's not sunny, that one will be evaluated to false. Has a discount, it can either be false or true. So here I had evaluated to false. So booleans are often used in comparisons and control flow. So control flow is a future topic and we're going to look at it the same way to the same comparisons. So for example, if you want to print Python, okay, print 10 is greater than 5. The output should be true because we are trying to compare. We are comparing 10 to be greater than 5. The output should be true. And then you're also comparing 3 to be equal to 5. The output will always be false. So let us head to Boolean values, that is true and false. So for example, is sunny is equal to true, and is rainy is equal to false. So print is none is sunny, we get the output as true, and you can also get the output as is underscore raining as false. So we can look at boolean from numbers. 0 is always false, while non-zero is always true. So for example, you can print bool of 0, the output should be false, and bool of 10, for example, output should be true. And printing boolean of -5, the same is true, which is a number. And moving ahead, boolean are from strings. So empty strings are always false, while non-empty strings is always true. For example, we want to print the boolean of empty string, and from your side you should also get the output as false. So moving ahead, you can also print the boolean of the word Python, and output should be true. So boolean are from list, tuples, and dictionaries. So let's just see an example. So for example, print boolean of an empty list. The result will be false because it says empty. So we can also print the boolean of a list with values. The result should be true because we have some values. I also can also print a boolean of empty dictionary or set. That should be false. The boolean of a dictionary with values, the result is true. Now moving ahead, you can print the boolean of operators such as and, or, and not. For example, a is equal to true, b is equal to false, and you can print a and b. The result should be false. Both numbers must be true. So you can also print a or b. The result should be true because at least one should be true. So you can also print not a. The result should be false because you're reversing the true to false. Then you can print not b. The result should be true, the same way we've just done and the previous example. So moving ahead, you can do some comparisons. For example, x is equal to y, and x is equal to 10, sorry, and y is equal to 20. So print x is equal to y. The result should be false because 10 is less than 20. You can also print x not equal to y. The result should be true because 10 is less than 20 or not equal to 20. So we can also print x greater than y. The result is false, and x less than y. The result is true. Also print x is greater than or equal to 10 is true. I can also print y is less than or equal to 20 is true. Moving ahead, on short circuit evaluation using boolean. So for example, print false and print won't print. So the result should be false because it will stop at false. And you can also print true or print won't print. True or print won't print. So the output should be true. It will stop at the true. And then we can convert values to boolean. So for example, print boolean of 100. That should be true. I can also print the boolean of 0. That is false. I can also print boolean hello is true because it's not empty. Then boolean of empty string should be false. Then so we can also print the boolean of empty list should also be false. Same way boolean of a list should be true. That is it. So we're going to look for another data type called list. So list is an ordered, mutable, or modifiable collection of items. When I say collection, you need to compare it to, for example, collection of different fruits, collection of different colors. It's like a combination of something. So that's what you call it, a collection of items. You can say a collection of students, or a combination of different kinds of students, different kinds of classes, different kinds of university, different kinds of political affiliation, different kinds of specific groups. So that's the example of a collection. So and list can store different data types in one list and are created using square brackets. So if you see anything, any collection that is created using a square bracket, then that's no, that is a list. Example, a list of numbers is as numbers is equal to 1 through 5, and we have mixed list. List can contain multiple data types or different data types. So, for example, we have mixed list of different items, and we have a list of the same items. And then list allow modification, appending is like adding something on top of what is already existing. We shall see this in practical examples. And we can also remove uh, some of the elements if we don't want. So for example, if you want to add number 6, you just say to the existing list, you say the name of our list, you say in this case is numbers dot append, and then we insert the number you want. So it will add 6 to the list. And if you want to check what is if you want to change what is in position 1 to be 100, the list at position 1 will be 100. Remember, list starts Python programming starts indexing at position 1. If I say indexing, it's like saying that, for example, here is number 1, 2, 3, 4, and 5. So number 1 is at position 0 in Python's memory, but in human memory it is at position 1. That's why we're saying that position 1 value will be changed to 100. Now if you print numbers, we have to get that 100 is indeed at has been replaced by what was on position 1. So let us navigate to VS Code. So lists, now we're looking at lists, creating and accessing elements. So for example, fruits is equal to apple, bananas, and cherry. So we can print fruit at position 1. The position 1, you get an apple. We can get the fruit at position last, which is cherry. And we can also move ahead by looking at how you can modify lists. So for example, list at position 1, we want to change it to blueberry, which will be banana will be changed to blueberry. So if you print, the output should be apple, blueberry, and cherry. Then for number 3, you can look at how to add elements to a list. So we use the append keyword. And for example, we want fruit.append orange. So it will be appended at the end of the list. So print fruit without should be apple, blueberry, cherry, and orange. Yes, fruits.insert, we can insert, but we should always remember an index. So at position 1 we are inserting mango. So not position 1 but index 1. So for example, print fruits, the output should be apple, mango, then blueberry, cherry, and orange. Number 4, we are going to look at how to remove elements from a list. We use remove keyword or remove method. So we are removing cherry, and the result will be apple, mango, blueberry, and orange, because we have removed cherry. And then we can pop out or removing the last element from the list. So we get it as the last as was orange. So we can print fruits. The result will be apple, mango, blueberry, because orange has been removed. And then number 5, you can look at slicing or simply indexing of list. So for example, numbers equal to 1, 2, 3, 4, 5, 6, 7, 8. So you can print numbers from position 2 through position 5. You get 3, 4 up to 5, and then you can print numbers from position 4. And then you can also print numbers using steps. So by default step of 2. So you can also print numbers in reversal order by colon colon -1. So you get it reversed. So number 6, you can check if an element exists. So for example, we want to print banana in fruit. Remember, banana, we had replaced banana, so banana is not in our list. So we can also print mango in fruits. So the output should be true because it's there. So we can also loop through. Kindly bear with me because I'm just focusing on coding section. There will be some kind of indentation, maybe errors from your side, but yeah, just be keen. I will provide the codes that are well formatted into my GitHub account. So for fruit in fruit, print fruit, the output should be the available fruit. So you can also sort a list in desired order. Numbers is equal to this, and then numbers dot sort we get in ascending order by default. But we can reverse that, or you can bypass that by numbers. Printing numbers, you get it as 1, 2, 3. So 1, 2, 5, 5, 6, 9. Now you can also do it in reverse order by using reverse equal to true. So by overriding the default one. So sorts in a descending order. So we print the number. The numbers is equal to output as 9, 6, 5, 5, 2, 1. And you can also do list comprehension. So it's just a way to make your working easier. For example, squared values, x squared for x in range 1 to 6. So all values from 1 to 6, 1 up to, let me say 1 up to 5 will be squared. So square of 1 is 4, 9, 16, 25, and so forth. So you can also find the length of a list using the len keyword. So you print the len, then fruit as an argument. So you get it is 3. So you can also copy a list by using the copy function or copy method or copy keyword. So copy fruits equal to fruits.copy, then print copied fruits. That will be apple, mango, and blueberry. Then 12, you can look at clearing a list. So we use the clear keyword or method, which will be print, and it will be an empty list with just square brackets. You can also do what we call merge two lists. For example, list 1 is equals to 1, 2, 3. List 2 is equal to 4, 5, 6. And then merged list is equal to list 1 plus list 2. And you can print the merged list. Merged list, we get 1, 2, 3, 4, 5, 6. And you can use extend method to extend the list. For example, list 1 dot extend list 2, which means it will get the output as of the above. It's the same as merging. So we're also going to look at dictionary. So dictionary stores data as key value pairs, and it is created using curly braces. So, and they're useful for fast lookups. For example, if you want to see the performance of a student, you just need an index number or a student ID. So if you insert a student ID, which are always unique, you have to fetch the exact student from the database. So that's what you call fast lookups. And for example, in this case, student Name is equal to John, age is equal to 25. Is graduated, for example, is false, which means that the student is already is still in session. So, and remember, we said dictionaries are created using curly braces. And accessing, and we need to look at how to access and modify the dictionary. So accessing and modifying a dictionary value. So let us head to VS Code. So moving ahead, we look at tuples, and we want to check how to create and access elements in a tuple element. So for example, fruit is equal to, tuple are created using round brackets. That's a point to note, while lists are created using square brackets. So fruit is equal at position 1 is equal to apple. And then fruit at last position, that's cherry. We can also reverse the order if we want, but we will move ahead. Now tuple are immutable. That's that's very important thing to note, that you can't modify it once we've created the tuple. So this will cause an error if we try to do modification. So for example, fruits at position 1 is equal to berry, we'll get an error, the type error. Tuple object does not support item assignment. So you run from your side and see the error. So we want to look at slicing using tuples. So numbers is equal to 1, 2, 3, 4, 5, 6, 7, 8. And if you want to print numbers at position from 2 to 5, the output should be 3, 4, 5, 6. 5. If you can print numbers at from first up to fourth, you will get 1, 2, 3, and 4. And you can also print numbers in steps of 2. So it will be 1, 3, 5, and 7. Moving ahead, you can also print numbers in a reversal order or reversed order. It will be 8, 7, 6, 5, 4, 3, and 1. 3, 2, 1. Just reversed order. And number 4, you can also check if an element exists in a tuple. So we use in keyword. So for banana in fruits, the output should be true this time. Mango in fruits, we expect the output to be false because we don't have mango. And number 5, you can look at looping through tuple. So we use four keyword for fruit in fruits. Print fruits. And the output is apple, banana, and cherry. Number 6, you can look at finding the length. Remember, I said I will help you format the codes on indentation issue. So for the length of fruits, we just print length of fruits we get is 3. As you can see, apple, banana, and cherry. So you can also count the occurrence of in your tuple, of elements in your tuple. So numbers is equal to 1, 2, 3, 2, 2, 3, 4, 2, 5. So for example, if you print numbers dot count and want to count the occurrence of 2, you get as 3. 2 is repeated twice, 3 So we want to find index of an element in your tuple. So for example, numbers dot index 3, what's there? So it is 3 already. 0, 1, 0, 1, 2, 3. It's already 3 in index 3. So concatenation, so combining tuples. So tuple 1 is equals to, for example, 1, 2, 3. Tuple 2 is equal to 1, 2, 4, 5, 6, sorry. And merged tuple is equal to tuple 1 plus tuple 2. And we get it, the result as 1, 2, 3, 4, 5, 6. And then you can see how to repeat tuple by using an asterisk to multiply through the number of times we want. So you get as hello, hello, hello as output. If you want 1 million times, you just need to multiply by 1 million. Then tuple unpacking, so removing each equivalent value to from a tuple. For example, person equal to Alice, age 25, and the job title is engineer. So name, age, job is equal to person. So it will be unpacked accordingly. So for example, if you say person print age, name will be is equal to Alice, person or print name, it will be 20 print age will be 25, and print in job it will be engineer. So we can also look at converting, how to convert a list to a tuple and vice versa. So we have an example. List of the fruits is equals to apple, bananas, and cherry, for example. Now tuple fruit is equal to tuple keyword, then bracket list of fruits. Now that is converted to a tuple by default, and you can do the same to a list. So if we print tuple of the fruits, you get now square bracket has been replaced with round brackets. Yes. Please practice from your side. So now list again to we want now to again use keyword list to convert tuple to a list. Now you can the output should be again in square brackets to confirm that that is a list, and no longer a tuple, or other people call it tuple. So it depends from your side. So you can also look at nested tuple, so which means tuple inside another tuple. So for example, John is 30, Alice is 25, and Bob is 28, for example. And now if we want to print the nested tuple at position 0, or you can say pair 1, that one should be John 30. At position pair 1 should be Alice 25, and pair 2, which will be Bob 28. Now you can also print, for example, if you want to print the age of John, it will be John is in pair 1, so it will be, we use square bracket twice square brackets, but now to be specific, 0 and 0, which means that we need we want the name, and 1 at 0 we need the name for Alice, and 2 at 0 we need the name for Bob. And if we do the reverse, for example, 1 and 1, we will get the age of Bob. So if we print nested, look at 2 point position 1, you will get 28, the way I've just told you. Now you can also sort tuple by converting to list. For example, numbers is equals to 5, 2, 9, 1, 5, 6. So if we sorted these numbers, you can say tuple sorted numbers hashtag we're converting to list. So we then sort then back to tuple. Then we can print sorted numbers is equal to, the output should be 1, 2, 5, 5, 6, and 9. So we can also single element tuple. We can also have single element tuple by using a comma. If you don't use a comma, that one will be just a string. So a single tuple is equal to, for example, hello, you should end it with a comma. So print the type of single tuple, you get the class to be a tuple. And if we do the same without a comma, we realize that it's a string, as I've just explained previously. So this is a string, not a tuple. So example, not a string. Remember, use descriptive words while naming your variables. So print not a tuple, type of not a tuple, the output is class star, which means it's a string and not a tuple. So we can also look at dictionary data frames. Not data frame, dictionary data structures. So for example, creating and accessing an element in a dictionary. So example, you have a person is equals to name Alice, and I told you that dictionary is a key value pair elements. So age 25, job is engineer. So if you bring person, a person's name should give you the name was Alice, and if you print the person's a person dot get age is still the same equivalent as previous line, you get 25, and a person dot get your salary, you can use a default value if it's not there to avoid getting an error, then the output should be not available. So, and you can also do what we call adding and updating elements to dictionary. So for example, we want to add a city, so person city as New York, and age, we want to update age to 26 instead of 25, and you can now print a person with updated values, and the output should be the output is as seen on the screen. So we can also remove elements through a dictionary, for example by using the delete keyword. For example, we delete job from that one, it deletes the job from the dictionary. So if we print dictionary of a person, we realize the job is missing now, and salary is equal to person.pop salary not available by default. So we don't have salary, so the result will be not available. Yes, we can move on by looping through a dictionary, and we can have an example using for loop. So we shall learn loops in the previous, not in the previous, but in the folder. In the upcoming classes, we shall learn loops in advance. So for in this case, we're just using some surface for loops. So for key value in person.item, print f key colon value. So the key value pair will be printed. So moving ahead, we want to check for a key. So print name in person. So this that should be true. That's just logical statement. Salary, it will be false. It's not there. And we can move on. Dictionary keys and values. How to check for dictionary keys and values. So you can print person.keys. You shall get the first elements of each dictionary. So we get a name, age, and city this time. If we print person.values, you should get like Alice, 26, and New York. You can also print person dot items, so you get everything from that dictionary. So you get big items, name Alice, you have age 26, and then you have city as New York. You can move ahead by merging a dictionary to other dictionaries. So for example, extra info is equals to hobby as reading, and age updated to 27. So person dot update exists, so which means extra information will be updated to a dictionary of a person. So if we print our person now, we'll have to get that hobby and the age have been updated. So name Alice, age now 27, and we have city the same as New York, and then now reading, hobby as reading, yes. Now we can also look at dictionary comprehension. So squared values of a dictionary. For example, x colon, so x as a key and x squared as value. So for x in range 1 to 6, so you have to square all the values. So it will be 1 to square of 1, comma 2 to square of 2, 3 to square of 3, all the way to 5 to square of 25 to 5. So you can also clear a dictionary by using clear keyword. So you get just empty curly braces. Yes, the output should be empty curly brace, which means it's an empty dictionary. So you can also move ahead to sets. Now you can see how you can manipulate sets. So have what you call set creation. So set also are created using curly braces, but they are not key value pairs as dictionary. So apple, banana, cherry, and apple. So it removes duplicates by default. So if you print fruit, you realize that one apple will be retained, but another apple will disappear. So you can also add elements to a set by using add keyword. Remember, list uses append, while set uses add. So you get the orange has been added at the end. Yes. Now you can do what we call, also can also remove elements from a set. For example, fruits.remove banana, and this one will raise an error if not found. But banana is there right this time. So fruit.discard mangoes. So you can also discard. There will be no error, or nothing will be displayed if the item is not found, but there will be no error. So set operation, you can look at set operation. For example, set 1 is equal to 1, 2, 3, and 4. Then set 2 is equal to 3, 4, 5, and 6. So if we want to print a set 1 given set 2, that's we call union. So we combine everything from set 1 and set 2. Yes, without duplicates. Then set 1 and set 2, that's what you call intersection. So things that is common between set 1 and set 2. Then set 1 and minus set 2 is like unique elements in set 1. Then print set 1 carried set 2 is just symmetric different. So we should be 1, 2, 5, and 6. So what is new from set 1 and set 2? Then we can also check numbers, membership inside the set by using in keyword. For example, 3 in set 1, it will be true, it's there. If you print 5 in set 1, it will be false, not there. And you can also loop through a set as well. So for example, for fruit, in fruits, we need to print a fruit, so the result will be fruits. So you can also set comprehension. You can also check on set comprehension. So for example, squares, so x squares for x in range 1 to 6. So if you print, the result should be 1, 4, 9, 16, and 25. So you can also do what you call set conversion by converting list to set, that is removing duplicates. Numbers, for example, is equal to 1, 2, 3. Okay, 2 is repeated twice, and 3, 4 goes twice, and 5. So unique number is equal to set, so we want to remove duplicates. And now you can convert back to to original numbers or to original list if we want. So frozen set, it is set like similar to a tuple that is immutable, which means you cannot modify. So example, frozen is equal to frozen set A, B, and C. So print frozen set, which will be A, B, and C. Now let us try to modify. Frozen.add D. It will give you an error. It will say type error. Frozen set object has no attribute add. So this is a summary table. Data type, description, and example. So int is a whole number, and examples include 10, -3, 1000. Float is decimal numbers, have 3.14, -7.5. Star or string is a text or characters. Hello Python. Booleans, true or false values, have true or false. List is ordered mutable collection. For example, 1, 2, 3. Alice 2025. Alice 25. Tuple is ordered but immutable collection. Immutable, which means you cannot modify them unless you do away with all list. Then a dic or dictionary is key value pairs, which means, for example, name John, age is 25. So final key takeaways from what we've learned so far. Choosing the right data type ensures efficient data storage and processing. So lists are mutable while tuples are immutable. So dictionaries are great for structured data and fast lookups. And I said previously that fast lookups is like looking at looking at something in relation to a pair. And I said like a student is linked to a student ID, and a student ID is always unique. So you will never find a single student ID being shared by more than 2 students. Then we also have string support various operations like concatenation, slicing, and repetition. So though we didn't look at strings in most cases, but strings in most cases we learn them more when we're touching on Django. That's when we learn more about strings and how we can manipulate them. Let us proceed. Now you have what you call type conversion. So in Python, type conversion, also known as typecasting, allows you to change a variable from one data type to another. So this is useful when performing operations that require specific data types, such as mathematical calculations or string concatenation. So I say string concatenation is just combining 2 or more strings to form your meaningful text. And we have various types of type conversion in Python. We have what's called implicit conversion, which is automatic conversion, and we have explicit conversion. So implicit conversion or automatic conversion. So Python automatically converts data types when possible. So this happens when converting from a smaller to a larger data type to avoid data loss. So for example, num int is equal to 10. So num float is equal to num int plus 25. And we know in our memory that num int is 10, which means 10 is being added to 2.5 to get a float by automatic summation. So if you print a num float, you are expected to get 12.5. So here Python converts num int or integer to a float automatically before performing the addition. So let us see this one. I'm going to look at typecasting, so also known as a type conversion. So and it's the process of converting a variable from one data type to another. So in Python, this can be done either implicitly That's automatic conversion by Python, or explicitly, that is manually by the programmer. So can I have some examples? That's float to integer. So for num float is equal to 5.7, num int is equal to int num float. Remember, int float to int, we have truncation, so the result should be 5. So you can also convert string to an integer, that is num string is equal to 25, and num int will be int of 25, which is 25 as output. So moving ahead, we can convert string to float. For example, num string is equal to 3.14, and num float is equal to float of num string, which in the result should be 3.14 without strings. We can also convert integer to a string. For example, num int is equal to 42, and num string is equal to string of num int. The result or the output should be 42, but in quotes. So we can also convert a float to a string. For example, num float is equal to 9.99, num string is equal to string num float. So you can print num string and get the output as 9.99, but in quotation marks. So you can also do string to list conversion. So for example, text is equal to hello, and you can find curly list is equal to list of text, and then you find the individual letters from the text. So the output should be H, E, L, L, and O, and it should be a list. So now you can also convert list to tuple. For example, list data is equal to 1, 2, 3, and tuple is data is equal to tuple. Using keyword then equal list data, and you can print tuple with the output should be with the round brackets. So tuple to list, in fact we were doing just reverse of what we've done before. So we get like 10, 20, and 30, and then list data is equal to the list and tuple data, so which means we're just converting back. So the result should be with square brackets now, which means that it's a list from a tuple. Now we can also convert list to a set. So, and set removes duplicates automatically. So for example, list data is equal to 1, 2, 2, 3, 3, 4, and set data is equal to set of a list, so which means you're removing duplicates automatically. So print set data, and the output is 1, 2, 3, and 4. So you can also do dictionary keys to list. So example, dictionary data is equal to A to 1, B to 2, and C to 3. So key list is equals to list dic data dot keys, and this is the output as follows. So output should be a list of A, B, and C. So we can also do dictionary values to tuples. For example, value of a tuple is equal to tuple dic data dot values. So you can print the values of a tuple, which should be output as 1, 2, and 3. You can also do an integer conversion to a boolean. For example, num0 is equal to 0, and num non-0 is equal to 10. Always use descriptive word while naming your variables. So print boolean num0, the result should be false, and if you print boolean num non-0, the result should be true. And that is it. So thank you guys, and see you in the next section. Explicit conversion, what you call manual conversion. So you can manually convert data types using built-in functions. So these functions ensure data compatibility when working with different data types. So, and the example or common conversion function include, for example, function. We have description, and we have example. For example, here we have int x. This means converts x to an integer and removes decimals, because we said integer are just whole numbers. either negative or positive without decimals. If we convert this one into integer, we get 5. And we say that integers, if you convert a decimal or a float number type to an integer type, it means that it will be truncated. Can you imagine 0.9 is truncated, and you're getting 5 here. So float x converts this is description what's happening here from this function float x. Means it converts x to a float or a decimal number. For example, 10, float a string of 10, you get 10.0. Star x converts x to a string. For example, string 100, you get 100, but it is quoted, so it's not a number anymore. So bool x, it will convert x to a boolean, either true or false. So for example, bool 0, you get false. So that's how we do it. So for example, num 5.7, if we convert them into an integer, you get 5. You say that this one will be truncated. Note, this conversion does not round the number. It simply truncates or removes the decimal part. So you need to be careful. And we have now converting integer to a string. So you can convert an integer to a string by using, for example, age is equal to 25. So age into a string, just say age is equal to star age, and you will get age 25 with quotation marks. So for example, your age is this, your age is plus. So this is an article string concatenation. So we are printing that your age is, now we get the value of this one from this one. So your age is age, so which means age string, so which means it will be replaced by this 25, and output is that your age is 25. So you cannot concatenate. You need to make sure that you need to understand that you cannot concatenate a string with an integer directly. You must first convert the integer to a string. Hope that is clear. Thank you guys for watching our videos and dedicating your time to listen to us. It's not in vain, and I hope you achieve your long-term objectives.